My name is John Immonen of Rapidform. Thank you for joining us today. All you joined on, a series of people joined on. Thank you for your time today to join us in the Rapidform and NX. And as if maybe a couple people joined in a little bit earlier and they've seen Rapidform SolidWorks and trying to figure out if they were on the right presentation. This is in fact the XOR and NX, so how to perform Rapidform solutions into Rapidform. Again, quick introduction. My name is John Immonen, Regional Sales Manager for Rapidform. I'm the Northeast U.S. Northeast Regional Sales Manager. And today what I'd like to show you is workflow inside of Rapidform for reverse engineering on top of scan data and supporting a NX platform, Siemens NX platform. And applaud any type of questions. We'll have a questions and answer at the end of this session, and we'll progress through this the presentation accordingly. So, who's Rapidform? So Rapidform, as you may have heard, has joined the 3D Systems family. As a reason, it's very new news to us. And to the industry that Rapidform has now become part of the 3D Systems. So now Rapidform is now known as 3DS Rapidform, and that it brings us into some new frontiers and new opportunities in the world of support in the 3D market for reverse engineering and also inspection for the upcoming or foreseeable future. For 3D Systems acquisition, Rapidform is a well-versed software to support that particular industry, and we at Rapidform are very excited to be part of that family. And Rapidform is known as known for the experience in developing 3D point cloud processing software to support effective solutions from start to finish, to from scan data to processing data and a usable CAD data. Such as NX, and also some other software such as SolidWorks, Inventor, or even Creo. And we'll talk a little bit about that in the future, but our main focus today is in fact Rapidform and how it supports the NX workflow. To date, Rapidform is more than 10,000 licenses that have been sold, and again we look for future sales as well. So as part of the 3D Systems group, the number is hopefully will escalate as well. Rapidform is known as an innovator of the 3D point cloud solutions. The innovation for 3D point cloud solutions is something that Rapidform has been very bold in the industry, or very class leading, if you will. With that class leading, we have 40 dedicated Rapidform research and development staff that are looking at new ways to process 3D scan data and how to process 3D scan data to an effective solution for our customer base. And as our customer base continues to grow, so does our focus as well. So what we take today, what we have to offer today, and also what we have to offer for the future. And again, as I mentioned, we have 40 R&D staff supporting just that workflow to ensure that we have an effective solution as well as market-leading solutions. You'll hear me say that fastest path to CAD, or some other type of scan to CAD methodology. So Rapidform is actually the innovator in that solution from scan to CAD data. That methodology, we feel that Rapidform is that innovator to the modern scan to CAD. With that, we hold over 30 patents to support that type of workflow. In addition to being class leading in development, but we feel we're also class leading in support. We get several accolades over the years about our support, and as we have 30 in-house engineers dedicated to the Rapidform customer and the customer base, whether that be a new customer, a prospective customer, or customers that we've had for a long period of time. Those customers we had over a long period of time, we treat them again hopefully no different than we do for a brand new customer. Our reseller network is more than 200 deep at this point, so that's basically in many cases, your first line of defense, or your first line of discussion in the current marketplace, and those are certified. Those trainers or resellers are certified to train and also support you in the event that they may not get your answer. We always have the 30 in-house engineers to support your needs. And what I'd like to finalize this by with Rapidform joining the 3D Systems group, it also interjects us into a publicly held company now, no longer private. So we have a nice motivation. We have a nice motivation level, and you can also follow us on the New York Stock Exchange under the ticker DDD, 3D, if you will. So very easy to remember, and hopefully you'll visit us and. In that aspect as well as the 3D Systems website. And also there's always information available for Rapidform on the rapidform.com website. Real quick, I'd like to talk about our customer base. So a lot of people ask, what is a customer base that Rapidform employs? I'd like to say that Rapidform as a whole has a very diverse customer base, and you'll see that on the screen, you'll see that there's several customers associated, you'll have automotive, aerospace, gaming. There's a little bit of everything. So customers look at who's your key markets, and you almost have to step back many times and say, well, there's a little bit of everybody. Every one of our customer base is in fact key. Even some of the smaller customers, they have large amount of licenses, and they support many industries as a whole. Even though they're maybe a small organization, but they support many people, and they have many instances of license, and they use the software very effectively. At any time, we like to discuss. We as Rapidform love to discuss our product and how we do installs. In the event that we can talk about some of the installs, we'd be happy to talk to you about how we may be able to help you, similar to how we've helped these customers. Quick snapshot about Rapidform. You'll hear, Rapidform, the fastest path to CAD. And what do we mean by that? How can we do that? So, we feel that Rapidform is the basic gateway from, if you will, it's interjected in the center here between your scanning device and your CAD software, your would-be CAD software. So there's always been that misnomer, say, I've got this really nice looking scan data and I could load it up in my CAD software, but what can I do with it? How can I use it? How can I effectively develop a model or develop a product to support that? So we believe that Rapidform XOR is that plug-in tool to act as your gateway to your CAD model. And something I'd like to enhance here, we show that, of course it's a lot bigger. So, the scanning, the introduction to scanning, you're able to port it over into it. And what we'd like to highlight here is there is a single dotted single line to that perspective software. So we have a very full comprehensive suite of tools available inside of XOR to support the downstream events into your CAD software. So when we bridge this gap, when we cross this gap and we go into those softwares, we know we have an effective model that we can populate these tools in the downstream events. So kind of in a nutshell, how can we do this? How can we employ this? We feel we have a superior reverse engineering methodology. The time to develop this type of impeller. So I'm going to highlight this impeller. This is a kind of a what do I say? It's kind of center of our proficiency, but it's certainly not the only thing that we can do. So the impeller is a very complex part, as everybody may see, or everybody may know. But then again, there's more complex features. But this impeller in a CAD software, as you'll see to your far right in your your traditional CAD software, and if you take maybe a set of calipers and measure some features and try to develop this model inside your CAD software, it can take upwards of 12 hours. Now, if we move to the center of the screen and we look at scan data, we start employing scan data. We enhance that, cut it in time. Hey, great, if you can cut something in your timeline process in half, great. That's a huge benefit, correct? So we take now 3D scanning software, cut sections, do some real simple geometry, bring that over into CAD or inside of AutoCAD, maybe a circular, kind of a redundant or maybe a a process that's iterative, if you will, an iterative process where you're taking scan data, taking section cuts, bringing that section cut into your CAD, and then you take CAD and you bring it back out to your scan software, see if it's correct, and that's maybe a circular methodology. But if we move to the far left-hand side of this screen, you'll see, hey, Rapidform believes that they can do this well within an hour. Right around about an hour time, certainly we can create this type of blade geometry. And I personally have done it time and time again on brand new models received from customers of scan data, and effectively create this type of model in fact an hour. So we believe we have an effective solution for supporting this type of parametric-based model. And is accurate. I'd like to always boast an accurate, solid model into your downstream CAD event. And today's CAD event today we'll talk about is NX. So, here I am talking about it a lot, but I think one of the greatest accolades that we've had is a U.S. Air Force funded study for reverse engineering. So U.S. Air Force said, what is the proper tools for reverse engineering? We have some legacy aircraft in there. We need to be able to replace some parts. So this document was generated unbeknownst to us, but it conclusively states that Rapidform is the only viable choice for parametric solid modeling to support 3D shape engineering and design parameterization. Very strong statement. Again, this was unbeknownst to us. This was presented to us. It was also looked at with other devices and other systems available in today's current market, and how they could to support the reverse engineering in that particular field. This page, if you'd like to read it in full, is available at our website at rapidform.com, and if you look at / reverse engineering, if you just go into rapidform.com and nose around a little bit, you'll find it pretty quick. So a nice paper is one thing, but you'll see a gentleman on the screen now. You get a celebrity endorses us as well. That's pretty powerful as well. So Leno, as you may know or may not know, has an extensive collection of collection of automobiles. So one of which he's got a 1935 Fraser Nash. Sorry, he's got a thermostat housing that was severely corroded over time, and with Rapidform, he was able to reverse engineer this part, and from the original part to the new part, in a very, very short amount of time. So now all of a sudden, now Jay's got this large list of parts that he'd like to, propagate through Rapidform XOR with this scanning device. That information is as well as available at our rapidform.com and to Leno. But also, if you go to Leno's garage, if you do a little searching on that, you'll also see some outtakes of that, and how we supported that, and hopefully we'll see some new things coming up as well. So let's talk a little bit about that workflow and how that was done. So I'm going to give you a synopsis of this workflow, and we'll take this one step further. And actually, I want to work on it as well. I want to get to kind of working on a part as fluidly as I can. And what I'd like to do is I'd like to discuss, first of all, the first thing we do is we scan and create a mesh. That's pretty much known in the industry, the scanning device. We can get at least a nice mesh model of it, and if you look at it, it's rather incomplete. It's rather incomplete because the part itself is rather incomplete. But with the workflow, with doing the feature recognitions, we can start identifying key features on this part that is available, and we can start creating some geometries on top of that. So on top of once we have these features, we can start creating some sketches. Very similar to what you do inside of NX. You create these sketches, and from those sketches, you're going to create features. And from the features, once we start building this profile, we can start adding parameterization. We can say, okay, the center of this bolt hole, the center of this bolt hole, the diameter of that inlet is key features. We can adjust those inside of Rapidform to make sure we have an effective model. As we start working through this workflow, we start adding details, and of course, we have to finish it out. We have to make this thing do what we do, a live transfer to CAD. We got to make sure this is a usable model in the industry. As we can, as we start building the model, we want to make sure it's usable as well in the downstream process. Okay, what I'd like to do is I'm just going to jump in here, and at this point, I'm going to jump into a Rapidform demonstration and discussing how Rapidform is in fact the fastest path to CAD. So on screen here, historically I just kind of roll back this model, but what I'd like to show you today is actually we're going to work on this part together. We're just going to do it as quickly as I can, and hopefully we'll be able to get through this part. So as you see, is this what I have on the screen before you is Rapidform XOR. And I'm going to show you some workflows in that. So you'll see there's 7 basic commands in the screen, and you'll see on the left-hand side there is a feature tree and a model tree. What I'm going to try to do is I'm going to try to build this feature tree and as well as model tree to enhance the workflow of this part. And what we'll do is we'll do a LiveTransfer after we're done with that, and we'll export that out and have an NX model we can take a quick look at and be fond of. So very first thing I do is we got a mesh. We can clean this mesh up, but you can see this is perhaps has a lot of holes in it. So what I'm going to do first, I'm going to do what we call a region group. A region group is going to offer a grouping of features on this part. So these features on this part is our ability to look at this part, look at the curvature of the information that's on the part, and let's try dissecting it a little bit further and see if we can't extract some CAD style features. Not to say that this is particular CAD at this point. What we're doing is we're still looking purely on the point cloud level, and we're trying to offer some intelligence associated to that point cloud. And once it returns here, we will see that it in fact does, it gives me a nice clean model here, and you'll see that this in fact is a freeform surface. That's a freeform, a planar surface, maybe a cylindrical feature. And you can see that it offers us, there's a planar feature on the top. And you see it's a good example. So you notice the part, I'm going to start modeling this part. I don't have this part in its entirety. I can also append some of these features together if I wish. Say I want to make, all these, maybe make all these things all part of the same region group. I have the ability to append this information together. Now I have a freeform surface that is much larger. And I'll do the same back here. And the only reason I'm doing this is just makes it easier to selection in a downstream process. And I just wanted to show you, not only do we have automated processes, we also have manual processes that we can enhance our workflow. Okay, so once we have this complete, we can start looking at this model a little bit further. Now we get freeform surfaces, we have planar features, we have cylinders. We have cylinders here, freeform surface on top because we have a little bit of rate of change here. So what I'd like to start out with this part is I'm going to make a quick centerline axis. Now this part is already pre-aligned. We've already done some pre-alignment. And if there's any questions on alignment, I'd be happy to answer those as well. But the basic alignment tools are available. So what I did is I just did a real quick centerline axis of this part. And what I'm going to do now is I'm going to we start doing sketches. I want to work on sketches as quick as I can. Notice I didn't spend a bunch of exhaustive amount of time cleaning the model up. So what I'm going to do now is I'm going to select a plane here, but I'm going to do a rotational plane. I want to do a revolve. So my rotational method, my central axis is an axis that I created, that centerline axis. My base plane is one of these real quick, and you'll see that we have a chance now to have a highlighted feature that takes a section cut. Now once we create the section cut, now we employ some very powerful sketching tools. These sketching tools will now offer us the ability to go in and do sketches. So in the pink here, I don't know how you can see that, but you'll see that this model is now turned pink. And what I'm going to do now is I'm going to start drawing some of these features in. If I take a feature, I'm going to draw a line here. If I just select that solid line, and you'll see that it is in fact a line. If I double click on the outside, you'll see that I can reduce it as well. Now, you can see that I can also select 2 lines here and make a little bit larger line, and maybe another line here. And let's draw a line out in 3D space here. Notice I didn't attach it. It didn't snap to anything that time. So I'm just basically drawing in free space. And what I'm going to do is I'm going to draw one last one to draw my center line. And now it's going to take the chance, take the opportunity and clean this up a little bit. So I have this line that is kind of freeform space, but look what it did. It automatically snapped as a horizontal. So now it's actually adding some parameters to that. So if I like to add some more parameters, I can also float around a little bit, and I can add a vertical constraint to this, and add maybe a horizontal constraint to this, and add a horizontal constraint to this. So I know when I revolve this part, I know it's flat. It's going to be in a flat state. So I can also move these around now that they're flat. I can also snap it to maybe the outermost portion of this, or I can take again an average of it. Okay. Now, once we have these drawn in there a little bit, now I can start fine-tuning this. Let's do a little bit of trim work, very similar tools to what you may see in your CAD system. And we can go through here real quick and just trim the part up. And I'm going to trim to the center line right here real quick. And last thing I want to do is the same type of tools. And I'm going to add a fillet in here. So I'm going to add a real small fillet in this area. So I can add any type of fillet I want, or I can actually snap to that feature there. I can also snap to this one. And if you notice here, what I have here is I actually have a numerical value that gave me an average, but I can also override my system at any time. It told me it was a 2.671392. So maybe this thing, me as an engineer, I should make this 2.5. Just to ensure I don't have any discussions with my my manufacturing department. Maybe this one I'd make this as a whole. So I have the ability to also add my designer's intent as well, or I can just leave it go as verbatim as a verbatim model. So I can also do a little bit of checks here as well. How well did I do? My question is, how well? I'm starting to do this, and how well is my part actually coming out? We have what I call my, I call it the accuracy analyzer here. It's an ever-present accuracy analyzer. So I can look at my deviation, and how you can start looking at a deviation plot, and how well is that scan data fit in this curve or features that I just made. I do a vector multiplier. You can see that, of course, at the ends I don't have anything. There's no scan data down there. But you can see in the areas where it matters, you can see a little bit of a trending here, so I can see what's going on here. But you can see, obviously, there's no scan data down here. So I'm about 40 microns off in this area. So I'm pretty good with that at 40 microns. And I'm happy that could have been any features that you may have created. So I have the sketch. I call it complete. Maybe I don't have it complete. Maybe I want to add some features, dimensions to this. I can also dimension this now. Maybe I want to add a dimension here. Again, maybe I want to add some dimensions here. And I can fully dimension it, fully constrain it. And you can notice that when I did constrain it, when it's constrained, it turned black. But it's not necessary that you fully constrain the model before you do the revolve. So now that I have this nice profile, and if I look at my scan data again, you can see that's a nice profile of the model that I intend to create here. So now I can start going into some of my tools, my extrusion tools, my revolves, or my sweeps, or my loft. In this case, I'm going to do a revolve. And it's asking me what's my axis of the revolve. You see it automatically, found that, and it went ahead just like it would do in any type of CAD software. It made a revolve. So now I have now I have my first 3D shape that I made. This is a 3D solid now. Now I can start working on this and start detailing it a little bit further and having a little further discussion. So let's move on here. So I have now this blade. The blade's going to be much more difficult, of course, to make. It's probably a little bit, you look at it's got a free-form shape. How am I going to build this? So I'd like to build this again as a solid. What I'm going to do is I'm going to try to get this outer profile first and build that outer profile. So I'm going to use that same tool once again. I'm going to do a mesh sketch once again on that plane, that base plane that I have down here. And if I move that base plane, I can actually move that profile of that base plane up and down. What you're going to see here is I really can't get there we are. Sorry about that. Now I see I'm unmuted, but I apologize. We checked out for a moment there. But anyways, getting back to my project here, you can see that if you move this part up and down, you'll see that the part in fact does. I can't really get a good profile of that outer leading and trailing edge on this blade. But I have another little node over here. If I grab a hold of that one, I can actually add thickness to that plane. So now everything that resides within that boundary is actually projected to that primary plane that I requested. So now I'm building out that primary plane. You'll see that here's my sketching view once again. And now I can start just working on this a little bit further. So I'm going to use some of my sketching tools once again, just like I did on that first profile. And I'll reduce my feature features here. So what we'll do is I'm going to use an arc. I'm going to use a 3-point arc here. I'll use a couple 3-point arcs, and we'll just kind of draw this part in a little bit here. And once I have a couple of 3-point arcs already established, what I'd like to do is add to those. So I'm going to use a tangent arc. So I'm going to actually add more lengths to that by adding tangency off these last features here. I just did a little mistake there. So we'll come back to that again. And we'll do a little quick one here. Oops. And we'll adjust this a little bit. We can play around with these numbers a little bit and get this to work just perfect now. So I'm going to make this actually straight. I want this leading edge to be straight here. So we can also force these to be tangent. And we can roll this back a little bit here, and we can adjust this so it dynamically adjust it, so you can see that. If it gives me a nice update. And let's finish this off by looking at this last little arc segment here. And of course, we got a little bit of trailing edge down here. Okay. And what I'd like to do is I can also, so since I want this part to go inside of this, inside of the model, what I can also do is I can also select features on top of my existing CAD, and I can convert those into entities that I'm going to sketch. Now I know I'm concentric. I know I'm always evened up with that particular feature. Oops, got out of my sketch mode. And so now I can start using that as a feature here, and I need to do a little bit of trimming with that. So now if I come in a little bit of trim work, I can actually trim this feature off, and I can use that part as my closed loop or my closed geometry. Now I have two final things to finish up here, and what I'd like to do is I'm just going to go ahead and close this arc off here, and you see that I can grab that arc right there. And last thing I would like to do is I'm just going to make a quick line. I'm going to make that line from the center line to here. And just again, just kind of sketching as I feel necessary, as it feels necessary. And what I'd like to do is I can grab a hold of this one as well, and maybe move that around a little bit. You can see that center line point. Maybe I want that to be concentric to the center line axis of the part. So I want this outer to be concentric. So I just pulled its arc center point and snapped it to the center. Now I can start doing my final trim, and now I'll have my final profile. And if you see that, makes a nice, clean model here. And the last little thing to close it off, I need to add some type of fillet here. I can also add, you just use my fillet command, and let's just go ahead and add a fillet here. You can see that I can just slide it out. I can actually slide it to a real sharp point if I want, or terminate it as such. Okay, now I have this nice profile. It's 360 degrees around the part, or around my profile, so I don't have any inclusions or no opening. I can use that profile, and what I'd like to do is I'm going to build an extrusion from that. So let's see what we have. Let's make sure we have enough. So I'm going to extrude that up, but I don't have anything on the bottom. I can also extrude down. Okay. And with those extrusions now, when I come back, I'm not going to merge it to my first feature, so I got my merge tab off. So there's a nice profile of my part. And now I got to create those faces. So let's suppress our solids for now. Let's talk about making freeform safe faces. So I got a freeform safe face. This is what I need to. This is the important feature for me now. We have a tool that's called Mesh Fit. Mesh Fit is going to real quickly just create a surface model, a surface of that face. Basically, vacuum form that plane down to the planar feature and made a nice freeform surface on us. I'm going to do the same thing here just to keep it moving here. And now we'll take that same in the opposite direction and do that same thing there. Okay, now we have these two nice surfaces. We can use our deviation plot to see how well we did. We want to know how well, so everything within green is within 0.1 millimeter. Got a little bit out here. Maybe we want to go back in and tune that up a little bit. Maybe not. Maybe we want to suffice the So 0.12, just under an eighth of a mil, so we're in pretty good shape. So we have these two surfaces. We have this nice solid body that we created that hopefully goes through both of those. And now we can use the cut command to cut our large surface bodies. So the first thing we want to create is cut is we want to select a tool body. We want to select the solid that we use to create that, and we want to highlight what we want to save. What part do we want to keep? So let's do that same thing once again. So do the same thing, the target body, and this time when I select, now I need to select that real small margin, the smaller part, and there I have my solid bodies now. So of course you can see, here's a nice profile of my blade. I got my ever-present accuracy analyzer. We see how well we did. Here's how well we did against that scan data. You can see it's a little bit blue inside that's still penetrating that outer ring. And what I'd like to do real quick is I'm going to do a quick rotation and add more blades to this. Last time I was running this, obviously I had it running 10. So let's see what it does when it returns. There's 10 blades. We don't need that many blades. This system's only asking for, in fact, 3 blades. Okay. And now I can merge these together, of course, and add my fillets. But for the sake of time, it's basic workflow. What I'd like to show you now is, how do we put that to do a live transfer to NX. The only thing I got to add, I didn't add the ring. So we have a function called LiveTransfer. A LiveTransfer is going to send that information, in this case, to either SolidWorks, Siemens NX, Creo Pro E, or AutoCAD. So let's send this out. Since I don't have NX, I'm going to have to show you a video of it, one I created last time that one of my coworkers did, but I don't have NX loaded on mine. I'm going to show you a quick presentation of it, and I'm going to make this information available to you after the web. It's obviously part of our regular demonstration that you'll be able to download it, but I'm also going to make the parts available to you as well, so you can review them in your own CAD software. So as you see, it's progressing. We're going to send this out to Siemens NX. We're going to do a live transfer to Siemens NX, and we're going to start at the first feature. So what it does is it launches a copy of Siemens NX on your system. So it needs to couple up, and it needs to have a clean connection. And you can see it's basically going to recreate everything that I just did. So basically that short and actually adds one more feature for us, is that outer ring, and export succeeded. It means we have a good model. So now we have the ability to go back inside of NX, and now we have it as a native product inside of NX. So all of those extrusions that we use to create, all those loft geometry that we create, the revolve, the sketches, these are all available to us now. We can edit that. We can make it, if I wanted to go back and make this a 10-bladed feature, I could also go back in and make this 10-bladed once again. And this is really, really nice, and again, it's again, it makes it nicely available to your downstream process. But the thing I'd like to hang my hat on is that feature tree. That feature tree, again, it's a native model. It's just not an imported element. It's a real NX model. Okay, what I'd like to do is I'd like to talk about a couple other parts here. If we can, I'd like to talk about some of my a couple other models that I have available. And sorry, I got to look for them once again on my system here. So we have other models available as well that we'd like to look at, and I'm going to hover over another one here. And this is a little more of a blade element that we did. This is a pretty common part for us, so we do this frequently. And with the frequency of this part, we also try to support a a fluid workflow into each software offering. And I call this kind of a simple blade. This is probably the simplest blade that you'll find. Again, more complex geometry, more information, and the intent here is to show you how the NX live transfer process. And you'll see it's rather animated because of the center. It's trying to rotate everything around center, but it has a nice animation process to see actually what I'm doing here. And you'll see that it did a live transfer once again to NX. Export succeeded. Now it is, again, as I stated, a real NX model. And I did all these all these the workflow that I supported this inside of XOR was exactly the basic workflows that I showed you with the earlier blade. So there's nothing really different here. I just wanted to take the opportunity to show you real quickly here maybe another different flavor of this model. So we're not looking at the same part, and again, I invite you to look at some of the other models we have available at the Rapidform.com website, and that will show you, a good workflow. There's just a ton of good information available out there. But again, the interest of this discussion is actually how do we support these workflows inside of NX. And you see that, here we are, we're just kind of playing around with the fillets and a radius. We can change those fillets. Those are fully editable features. So you go again. We're not just working with a static model. It's not a model that we're continue to. So I'm going to start just real quick, and what I'd like to do is just take a moment and highlight some of the new features inside of Rapidform XOR 3 Service Pack 1. So very similar to what I did earlier. I'm just going to kind of real quickly just go we've employed some new tools inside of XOR 3 SP1 that help the operator build a faster, more efficient model. So what I'd like to do is show you the kind of the direction that we're going in. So earlier I selected that plane, and that's the surface, and I did these extrusion. But now we've added some new tools to where we actually just automatically we employ some wizards and some automatic features. So these automatic features are available by right-clicking, and I can say Insert Merge. And once we do the Insert Merge, we automatically get that extrusion that quick. So automatically this extrusion wizard was prompted, and say, okay, we can automatically extract that. See, what was it, about 3, 4, maybe 5 button clicks? I have this 3D solid. Okay, very similar to that. We have the same tools available now. Once I have the feature created, I have this cut. I can cut this geometry, and I'm going to go ahead and cut this real quick. And what I'll do is I'll turn my solid body back on. You can see that I just cut that surface with that imported surface, or not imported surface, but that auto surface by right-clicking. And what I'd like to do is just carry it a little bit further, and I'm going to use this surface this time. I'm also going to do another cut. I'm going to use a extrusion cut method. So I'm going to use my extrusion wizard, and I'm going to do just that. I'm going to go into extrude, and it's going to go ahead and make a feature here. You see it automatically created that feature, and you see my solid bodies once again. If I just keep hovering over these and keep switching them back and forth, and now I'd like to do the same thing to these other features. I'm going to do all of these all together real quick because they're all in the same sketch plane. Okay, now we've just removed those real quick, and I'm going to do one last one. Now this one's kind of tricky here. So we don't have much margin there. It's pretty narrow over these, so it may need a little bit of help. I'm going to take this same thing, do a cut, and you're going to see it's going to get a nice profile around here. It needs a little bit of help here. And let's advance, and let's see how well we did. So it's got a little bit of bumps on the side, but we can actually reduce its resolution a little bit and see if I can't get a nice curve. So now it's got a nice two tangent arc segments, and it makes a nice cutout for us. Okay. So in that very, very short amount of time, I was able to create this solid body. And it's kind of the direction that Rapidform is going, and what we're doing in the near future. You see these two tools to be continuing to be enhanced. So the last thing I need to do is I'm just going to add a couple of real quick fillets on here. And if I look at this fillet, you can see that 5 millimeters just didn't quite work. And let's back up. So 5 millimeters is a little bit too aggressive. Let's use this little toolbar here and say, let's estimate radius for mesh. 1.206. Let's round this up to 1. And let's select tangent propagation. It's going to go all the way around this part. And you can see that, real quickly we can add our fillets across the part. And of course, I'm going to go to my deviation plot and look at this a little bit further. And you can see the deviations. It's a little bit up here. Maybe I'll go back in there and tune that up a little bit. But real short amount of time, I've got a really nice, crisp-looking model to support it. So let's look at this model. Same thing, we're going to do a live transfer to NX from this model. You'll see that here's our model in Rapidform XOR. And what we'd like to do then is, of course, look at the features that I created. And what we'll do is, again, we'll export this to. We'll take these full feature, full model in the feature tree, and we're going to, again, Siemens NX. And you'll see the workflow as well, or the live transfer process once again for this. There's a base sketch, surface I used to create to cut it, the cutout, last couple cutouts real quick here, and export succeeded once again. So it's all the radius, all the fillets there. So now we're ready to take a look at this again once we're inside of NX. Okay, so again, it's kind of redundant here. So what I'd like to do is I'd like to go back to our presentation here and talk a little bit more about some of the areas of expertise or areas of interest inside of with Rapidform XOR. I'd like to kind of recap on it a little bit and see what kind of projects we're working on. So I'd like to show kind of a gallery here. So here's a automotive-based gallery, and so it shows you a V12 engine from from some racing industry, as well as a F450 chassis on a upper left-hand corner, as well as a 4-cylinder engine. So you see that these are parametric entities, and you see the power of this Rapidform XOR. You can get a very detailed model. The models, of course, I showed you, for time discussion, anyways, is they're rather simpler. So I'd like to talk about aerospace and transportation. You got the upper left-hand side. You got blade and airplanes and boat hulls or boat inserts. Consumer products, so as we all discuss, there's many opportunities for consumer products in today's industry. So that's one of our big market. One of the ones about every interest of how anybody works is the Apple product. It's a very interesting proposition. How can we be very quick to market and reverse engineering? So there's a lot of interest in the Apple products, as well as sunglasses and just the general tooling or general consumer product. And going into segue into tooling here as well as we have some really nice tools to be able to develop reverse engineering tool, as well as update tools. So on the left-hand side we have a product here which we actually take the information in and we actually morph the CAD data to represent the CAD data or an as-built condition in this tool. The tool may make some changes over a period of time, and we want to be able to capture that in the CAD environment. Again, it's just a couple more products here: prosthetics, a gas mask, and some bridges. It's a kind of, as I indicated earlier, we have many solutions that we support in the market. So it's not just any one definitive market; it's multiple markets. Okay, again, I thank you for your time today. I'd like to open it to this point forward. I'd like to open up for questions and answers, and I'm going to invite Shane Adela on with us for questions and answers. But again, I just wanted to real quick make a reintroduction to myself as John Immonen, Regional Sales Manager for Rapidform. What I'd like to open up now is questions and answers.
Hey John, it's Shane. Thanks for the great presentation. Do have a couple of questions here, and if anyone else has another question, please feel free to ask them type them in there. John, the first question we have is, what other CAD software products can XOR live transfer to?
That's a good question, Shane. Thank you. And the person who sent it out. In addition to NX, what I showed you, you'll see a very similar workflow to SolidWorks, Pro Engineer, Creo, I should say now today, and also SolidWorks, or SolidWorks and Inventor. I missed Inventor.
Thanks, John.
You'll see that. You'll see that. That was part of the call down menu as well.
Thanks,
Go
John.
ahead, Shane. Thank you.
The next question, does Rapidform offer training, and what are some of the training options?
Yes, training. Training is always done at the beginning of every month, the first full week of every month in our Denver, Colorado office. So we're always available for the first week. So there's a limited slot that you can do. So that information is always available at our rapidform.com website under support, and you'll see training, and that's always done in our Denver, Colorado office, and it is also done in several other places throughout North America. But you can also offer and request on-site training. We can actually bring one of our trainers onto your site as well. And third, I'd like to offer as well is we have several trained resellers throughout the country that also can support the training in a more local area.
Thanks, John. The next question is, do constraints pass into NX sketches, or do they need to be reconstrained?
Another great question. So again, I apologize. I really didn't spend much time on that based on our time we have today. But yeah, everything that I would have created as a constraint, you've seen in the earlier model that I did the first one, I created that profile. I added that dimensional aspect as well as I edited the diameter. So those constraints will in fact carry over. To note as well, Rapidform XOR is built on top of the Parasolids kernel, so everything that we create on top of that Parasolids kernel is viable inside of NX. So you don't have to recreate it. But if in the event, you can also recreate it or reapply that information inside of NX as well. You have the ability to do it on both sides. The benefit on doing it on XOR, you have the scan data to highlight or to be able to see if your constraints are correct. Next, Shane.
Thanks, John. Another question here is, I have a highly complex shape with many 3D curves. How can I input even the smallest details?
Yes. So that would, depending on the complexity of the part, of course, you would build freeform surfaces. I only built a couple of real simple freeform surfaces. Now you're talking about much more complex geometry, and you would build that very similar. You'd build the surfaces, you'd break up the data in a little bit further sense as we did with our region groups, and the region groups would make smaller patches or smaller detailed areas of interest. You can be very, very definitive and very small detail on a part, and depending on the resolution of your scan, of course, it's going to, if you can scan it and create it from the scan, if you can see it in the scan data, of course you can model it. Hopefully that answered the question.
And then on that same train of thought there, what about holes in 3D curves? Can you
holes in 3D curves? Something else there with that?
Nope, that's it.
Okay, yeah, holes. Of course, I didn't do any holes as well, but that's one of the main functionalities of a parametric model. Or if it was to measure a hole on a feature, maybe I didn't have 100% of my scan data on that feature. You can still override the system and maybe make two holes collinear, or on the same axis, if you will, or along a line. We can make round features. We can also make oval-shaped features if we wish. Basically, anything you can construct on a sketch, and you can extrude through a part, and circular or partial of a circular shape. If you can sketch it, you can basically create it. And also, what I'd like to add to that is maybe you have something as well with the whole feature. Maybe it has a little bit of draft associated to that. With the scan data available, you can also measure what that draft is.
Okay, thanks, John. One more question here real quick is how well do the models transfer to an STL file or a Gerber file?
So STL file is actually what I started with. So what we really didn't discuss, the model that I first pulled up was in fact imported as an STL. But if we roll back a little bit further than that, we can bring in just a raw point cloud, ASCII style point cloud or 3D point designation in 3D space, and we can build that all the way up to that STL model. We do have that ability in our XOS and XOR product to create from point cloud to STL. In fact, in this case, when I did bring those in, all those models were STLs as I brought those in. And that's generally inherently inherent export from a scanning device, or if we even do with our live scan, we also have the ability to scan inside of XOR, XOS, and XOV. We can collect that data as well in our own with our own utilities. But hopefully I answered the question on the STL. I actually started with an STL in those particular features, but we can also bring in just a raw point cloud and process that raw point cloud to generate an STL.
Thanks, John. I actually do have one last question that came in. Can we skip using?
Great.
Here's the question. Can we skip using Sketch and just create surface and then volume from surface?
Oh yes, but if the part just had pure freeform surfaces on it, the answer is absolutely. I could just I could use surfaces on each side, either side of the model. I could have done an extrude, like on the cylindrical feature in the center. I could have just did a revolve and made a surface there, made a plane on top of it, and did a trimming of it. And once they were trimmed, maybe I added some fillet radiuses to that. Maybe I do an offset to the center of the hub, and I could also build that all as surfaces. I chose to build that as a solid, but you can, and maybe you only have like sheet metal parts or something like that. It's only single-sided. You can absolutely build, single sheet surfaces inside of Rapidform XOR, and build those surfaces and trim them, trim and merge them if you want. Trim, merge, and also intersect them with a fillet radius. But by all means, we have that tool as well. Again, in the short amount of time we have today, we only have a snapshot of what the functionality. So my intent today was to quickly show you the workflow inside of Rapidform XOR and how to get that out to NX. And I'm happy to talk about any other further needs that you may have, more of a one-to-one basis if need be. I'm sure any one of our representatives of Rapidform would be happy to do that, as well as our resellers.
Thanks, John. And then just to clarify too, on one of those the previous questions, we can export the files as an STL file as well, not only
Yes.
import but export as well.
Yes. So if I just wanted to, if I wanted to say I had that nice, pretty model here, I could also export this purely as a mesh. So I want to turn that into a mesh. I can select that, convert this solid body that I created. I can create that back out and create a mesh from it, what I just did there. Now if I highlight that, so there's the mesh I just created, and that can be exported as an STL.
Thanks, John.
That's question. Yeah, this is. Well, appreciate your time today. Certainly, we at Rapidform, you're happy to answer any type of questions that you may have, and look forward to further servicing any questions that you may have, as well as the information that we made available today. Or everything we have, we'll be able to recreate this or put this up on our website, as well as we'll be able to make the information that we've created today available, as well as the videos for your later review. Okay. So with that, I guess I'd like to once again thank you for joining us today in our presentation of Rapidform XOR to NX, LiveTransfer to NX. And again, we'd like to offer any further questions you may have to follow up with us in the near future, and we'd be happy to follow up with you. With that, I thank you, and you have a great day. And Shane, if you have anything else, feel free to offer in.
That's it for the questions. Thanks, everyone, for joining the webinar today. We appreciate your time, and it will be posted on YouTube and on our website here in the near future for your review. Like John said, you'll be receiving an email directly from GoToMeeting with a link to that video recording either later today or early next week. Thanks, everyone.
Thank you. Have a great day.